Welcome to Plenty of Things to CIWRO, a series highlighting the individuals of the Cooperative Institute for Severe and High-Impact Weather Research and Operations, or CIWRO. CIWRO promotes collaborative research with NOAA to improve the understanding of severe and high-impact weather. CIWRO is housed in the National Weather Center in Norman, Oklahoma on the University of Oklahoma campus. In this special series, we learn about the journeys that brought individuals to CIWRO and what they do beyond their incredible work within our organization. We hope you find these stories inspirational and discover more about opportunities in meteorology. Let's get to know the amazing individuals in our organization.
My name is Charles, and I'm actually from Leadville, Colorado, which is a little town up in the mountains of central Colorado. And growing up, I was just always interested in the weather as a little kid. So was my dad, and so we shared that together. And that really just caused me to know that I always wanted to be a meteorologist. So that led me to OU, and then ultimately I got hired at CIWRO. And so the research I do at CIWRO involves weather radar and learning new things about storms using weather radar. And one of the most important pieces of that is actually working with the people who use radar to make decisions, like National Weather Service forecasters and emergency managers. And really our goal of working together is just to make the forecasts and warnings even better than they already are.
So I am a research scientist, and basically what that means is that I am doing research science with forecasters. And so a lot of my work is involved very closely with the forecasters and developing tools for them to use. So for example, one of the projects that I do is I look at the output from computer models or computer weather forecasts and take a lot of those different aspects of the forecasts and combine them into products for the forecasters to use so they can get a lot of information in one glance. Another part of my work is involved with NOAA's Hazardous Weather Testbed, or HWT, where my team and I bring in forecasters, researchers, and model developers from all over the world. And we really look at these models to determine what makes a forecast good and how can we get these computer models to develop better and better forecasts. So it's really fun work. I very much enjoy it. And what I really like about it is that I get to work so closely with the forecasters. And so I know that the research that I'm doing can really benefit them.
Well, I'm Greg McFarquhar, and I'm the director of CIWRO, which of course is the Cooperative Institute for Severe and High-Impact Weather Research and Operations. But I'm also a professor in the School of Meteorology here at the University of Oklahoma. So in terms of what I do for my job, I really help set the scientific direction for CIWRO in coordination with all of our external partners and stakeholders. I also represent CIWRO in meetings to our stakeholders and funding agencies, and I participate in a number of external and internal committees that are all related to the themes of CIWRO. In addition, as my role as a professor in the School of Meteorology, I perform my own research that deals with determining the microphysical or small-scale properties of clouds by flying aircraft through those clouds and using that information in combination with models of clouds and satellite and radar retrievals of clouds to learn more about the processes occurring in clouds and how to represent them in models, ranging all the way from very fine resolution, small domain models, to numerical weather prediction models, up to Earth system models.
What my research at CIWRO focuses on is studying chemical weather, or the influence chemistry and aerosols can have on weather and vice versa. This type of work is really important for developing air quality models that can tell us about pollution in cities, or to explore how tiny particles in the atmosphere can boost or hinder clouds and thunderstorms. We don't have a lot of data on temperature, aerosol and trace gas concentrations, or moisture from 30 to 3,000 feet above the ground. And so to collect more data to feed into our models and forecasts, I use uncrewed aircraft systems, or UAS, that are equipped with a variety of sensors to take measurements as they ascend through the lowest parts of the atmosphere. Right now, I'm developing a platform that will focus on looking at the vertical distribution of aerosols so we can better understand how amounts in the air can relate to what satellites see and what ground stations measure?
So I'm currently a postdoctoral fellow at CIWRO, which basically means that I get paid to do research all day, which is great. I love doing research. Particularly for CIWRO, I study severe thunderstorms, particularly supercells, and the tornadoes that they spawn. So I study observations collected from the field in the vicinity of supercells and tornadoes, and I also study high-resolution computer models of supercells and tornadoes to better understand kind of the airflow within them and how they work, what makes them do what they do, and hopefully to better predict them one day. So that's a little bit of what I research at CIWRO.
I am a research associate with CIWRO supporting the Atmospheric Radiation Measurement, or ARM, Data Quality Office. My job is to keep an eye on all of ARM's weather and climate data and make sure that it's of good quality. Meteorologists and other scientists and atmospheric scientists often use weather data in their research, so it's important that the data we provide is accurate and reliable, because if you were doing research on a paper, you wouldn't want to be using bad data, because then it would sort of make your research paper not a good one. ARM operates nearly 200 weather instruments located all over the world that collect weather and climate data at the same time. And so we write computer code that takes the data collected from these instruments and creates graphs and pictures that we could look at from our own computers. And that in turn makes it easy to figure out when a weather instrument is broken and may therefore be collecting incorrect data and needs to be fixed. So if we're looking at a plot and we see something that looks weird, we tell people who are on site and who can go in person and fix the instrument. And then that way the data is fixed and flowing properly after that.
In my work, I'm interested in studying the physics happening in the lowest part of the atmosphere, specifically about the lowest mile or so. And that's really, in my world, that's really where all the exciting stuff happens, where we're looking at exchanges of heat and water vapor and wind between the land surface and the atmosphere. And what I try to do is try to better understand some of those physical processes so that we can better put those into weather forecast models. So to do this, I get to use all sorts of meteorological instruments. A lot of our work is based using micro-meteorological towers that are deployed at the surface, of course, but then we can get information about what's going on higher above those towers using drones by doing routine profiles, whereby we'll fly drones frequently. We can fly those up to, say, 1 kilometer. We can get information on the temperature and the moisture in the wind fields. We're also using drones to, we're evaluating different techniques for getting fluxes from drones, looking at how quantities like heat and water vapor and wind change at high frequency, looking at exchanges there. We use weather balloons. We use really anything we can get our hands on to study that part of the atmosphere. We work with folks out in Boulder that do work with remote sensing, like wind lidars, that sort of thing, radiometers, other sorts of, again, remote sensing platforms from the surface. And then by taking all this information, and what we can do is we can develop new representations, new parameterizations for how the land surface and the atmosphere interact. And then this information helps go into our weather forecast models, into the boundary layer and surface layer parameterization schemes to help make them better.
Like I mentioned, I've just always been interested in the weather, and even more specifically, always interested in severe weather, thunderstorms, hail, damaging winds. So I knew that I wanted to do something related to weather, whether it was forecasting or research. I just wanted to be involved in the weather. I'm interested in forecasting, but I've found over time that I really like the research aspect of meteorology. Where you can just spend time studying different aspects of the weather, learning more about it, always trying to solve a puzzle or solve a problem, and then take that completed puzzle to the decision makers to help them produce the forecasts or produce the warnings. And that's really what motivates me, is knowing that the work that we do can help people prepare for severe weather and help people be safe during severe weather. Because I just want the public and people to be as safe as possible while that's going on out there. And if I can play any little piece in that, that makes me really excited.
I frequently got asked whenever I was going through college, oh, are we going to see you on TV? And that just wasn't really a path that I was called to. I was much more interested in behind the scenes and how the the broadcasters who were giving us the weather, how did they really gather all of their information to understand what the weather was going to do? So I was really inspired by figuring out how to understand the workings of weather. I actually used to be afraid of storms whenever I was a kid. And so I thought, okay, if I can understand these, then maybe I won't be as afraid. And turns out that's what happened. I also was fortunate enough to do an internship with the Storm Prediction Center whenever I was an undergrad. And I drove to my internship. And the path that I drove went through Joplin, Missouri in 2012. And so it was a year after they had had a devastating tornado hit that community. And just seeing where buildings had previously been and the impact on people in that community really drove me and inspired me to try to do research to help people in the path of these types of storms. The United States is such an interesting country in that we have so many different kinds of severe weather. We've got nor'easters and hurricanes, tornadoes and other severe storms, wildfires, really all these different kinds of severe weather that affect the people who live in the United States. And so I really saw an opportunity to help protect life and property in a variety of different ways with meteorology.
I was working as a professor at the University of Illinois when I saw a call for the position of the director of what was then CIMS, or the Cooperative Institute for Mesoscale Meteorological Studies, which is now morphed into the CIWRO, the Cooperative Institute for Severe and High Impact Weather Research and Operations. I was inspired to apply for that position because I thought if I was the director of one of the major research institutes in the United States, I could have a bigger impact on the advancement of science than I could if I was working as a faculty member where I had a group of 6 or 7 people. Further, I like the ability to lead an effort to advance goals that related to developing improved forecasts, warnings, and watches that would contribute to NOAA's goal as to reduce the economic damage and loss of life, which is associated with severe and high impact weather.
I actually didn't even start out in meteorology or atmospheric sciences at all. I actually started out as a biochemist. And during my undergraduate career, I actually did an undergraduate research experience where I got exposed to environmental chemistry. And I thought it was really, really interesting to learn more about how the Earth cycles worked and study how they were changing. So I decided to pursue a doctorate in chemistry, and I focused my work there on how chemical components inside aerosols, or those little particles, are transformed as they move throughout the atmosphere, and how they could lead to the formation of new particles or how they interact differently with sunlight. But all of this was done in a lab. So I got into studying things out in the field when I took on a project to better understand how we could quantify or measure local scale emissions with the UAS. And I discovered I really liked field work and how the chemistry interacted with the weather conditions. And that sort of set me off on a little path that brought me here.
That's a great question. I always love when I tell people what I do and that I'm a researcher, and then I still get the question, so when am I going to see you on TV one day? And I just have to laugh and politely explain to them that that's probably not the case unless there's a tornado behind me on a field project or something. So how I got to where I am today professionally, I got my 3 degrees in meteorology. I got my undergraduate degree in meteorology from Penn State University in 2015. And then I came to OU and have been here ever since after that. So in 2017, I got my master's in meteorology. And then in 2020, last year, I got my PhD. And obviously since then I've been working for CIWRO as a research fellow. So that's a little bit about how I got to where I am today. I was very grateful to have the opportunity to start research as an undergraduate around my sophomore year, I think, at Penn State. It was a class project that kind of turned into an extracurricular research project that eventually led to a publication and several presentations at conferences. So from that experience, I learned that I liked doing research and that I wanted to pursue graduate school. And I was very grateful to have the opportunity to do that at OU. And that's when I learned that I really had a passion for it. And I really love to do research, and that I could probably do it for a long time and be happy to do it and get paid to do it. So that's how I ended up where I am today. But like you said, there are obviously many other careers outside of broadcast and research too. In terms of what inspired me to do what I do, one of those things is just a fascination for clouds in general and severe weather. When I first came out to Oklahoma, I saw my first most severe thunderstorms and supercells, and that fascinated me. I'm not one of those people that has a story from when they were like 4 or 5 or 6 years old and, you know, your house got hit by a severe thunderstorm or a snowstorm or something. I don't think that was the case for me. I think I watched the movie Twister during a thunderstorm in high school, which might have done something to me. I'm not quite sure. That might have been it. But in high school, I just found myself cloud gazing more often than not and just decided that I had an interest in it and pursued it. So that's one inspiration for me and why I do what I do today. The other inspiration is working with students. So aside from having a passion for research, I really have a passion for working with students, both in the classroom as a teacher and a lecturer, and also as a research advisor. So I'm currently working with undergraduates, master's students, and PhD students with their own research projects, whether it's related to their theses and dissertations or a side project gig too. So those are some things that inspire me to do what I do.
So I wouldn't say there was one specific moment that made me choose my career path. I would say growing up in Chicago with all this crazy weather definitely helped influence me at least a little bit to get into meteorology, but there wasn't one like aha moment that I had or anything like that. Right out of high school, I didn't really have any idea of what I wanted to do, but I knew that I liked weather. So my undergrad university unfortunately didn't offer meteorology as a major, but they did offer earth science. And to me, that sounded like the closest I could get to meteorology. So I picked that. And then I knew that I could go to grad school for meteorology later on. And while I was in undergrad, I took a bunch of extra math and physics classes to sort of prepare me for grad school and look good on grad school applications. And then I started applying my senior year, and then I was accepted into grad school, got my master's in atmospheric science, and I was applying to any weather-related jobs that interested me after that. I would say my inspiration for my work with CIWRO comes from knowing that a typical workday can change drastically from day to day. I could be coding or helping mentor students. We have student analysts who help us monitor the data as well. They're undergrads here at the University of Oklahoma. To discussing the best way to implement a new idea with another researcher. This type of thing provides many opportunities for collaboration with other like-minded scientists to come together and efficiently solve a problem, which is the type of work that I enjoy.
I've had a lifelong passion for the weather really since the age of 3. I grew up about 90 miles northwest of DC. I remember just watching the TV as a little 3-year-old, getting super excited whenever the guy with the colorful maps would come on TV. So I have had the weather bug for as long as I can remember. In undergraduate, I briefly went pre-med, went that route for a few semesters, realized that wasn't my cup of tea, and then switched back to my roots in weather. And I was very fortunate enough to go all the way through, got my doctorate, and really do have the proverbial dream job of being able to support CIWRO and be able to support also NOAA ARL's mission and be able to do some really amazing science. I know it sounds cliche, but I mean, I feel like I really, every day is a fun day. I mean, you have to deal with the occasional annoying things, but generally it's very fun and always exciting to come to work.
Growing up in Colorado, I'm definitely a fan of mountains and hiking. So I like to take every opportunity I can to get out and do hiking, whether it's here in Oklahoma or in Colorado, Wyoming. I really like getting out there and seeing what's out there in nature, which is kind of related to meteorology too. Like I like looking outside and just looking at the clouds and the storms. And I think all of that kind of ties into photography. I really like getting out and just taking pictures of cool looking stuff. Whether it's while I'm exploring hiking or just driving around and finding cool stuff to take pictures of. I like to spend a lot of time doing those things specifically.
Well, obviously, I love to travel, as maybe was alluded to by me driving to Norman from Pennsylvania. So I very much enjoy travel. Even in the pandemic, there are a lot of different sites and places that my husband and I have discovered locally within Oklahoma that are some beautiful outdoor spaces. I absolutely love to read. I read pretty much anything and everything, but particular favorites are science fiction and fantasy novels. And then I've recently gotten into gardening in the past year, which is something that I had never had an interest in before, but now I really like just watching the flowers grow and seeing what comes up from the garden. So there are a bunch of different hobbies that I like to enjoy. And of course, a lot of that also involves hanging out with my husband and with our cat, who may or may not make an appearance in the background. She's kind of chilling out of view of the camera right now, but you never know with cats, right?
I probably have 3 different hobbies. I like to run, I like to travel, and I like to play ice hockey. Unfortunately, I'm not doing the last one right now because of COVID, but I try to do the other 2 to the extent I can. I've been to 41 different countries, and I'm looking forward to continued travel once the pandemic ends. A lot of the locations I've been to have been touring after various scientific missions that we've conducted in those locations. So we go to these different locations to learn more about clouds that are occurring in different areas of the world. So I've been to locations as far north as the Arctic Circle in Alaska. I've done projects studying tropical oceanic clouds in locations like Darwin, Australia, and Cayenne in French Guiana in South America. I've also done projects in Namibia and Sao Tome and Principe, where we were trying to study the impacts of biomass burning on stratus occurring off the west coast of Africa. And I've also done projects in the Maldives, a set of coral islands south of Sri Lanka and India, where we were looking at how the aerosols generated by the Indian subcontinent affected clouds. One of the last experiments I did, we were based in Hobart, Australia, using aircraft to study Southern Ocean clouds, basically transiting all the way from Hobart, Australia to within a couple 100 miles of Antarctic. So as part of some of those projects, sometimes I can get time to do additional travel after the projects to see more about the world.
Most commonly outside of work, I like to play softball and do yoga, along with doing gardening projects around my yard. I'm also a really adventurous cook and like to learn to make things from a variety of different cultures. Like a lot of people, I also got into baking over the pandemic, but my specialties are scones and not breads. So I also like to play games of all varieties. So video games, board games, tabletop games. I find it's just a really nice, relaxing way to unwind at the end of the day. So those are just a few of the things I like to do, but a good portion of them.
So I love to play piano is one thing that I like to do. I'm very grateful to have a baby grand piano at my house that I play pretty much every day. My wife can back me up on that. I also love to play soccer, and I also, maybe surprisingly, love to ref soccer. So it's possible to do both and hopefully not be hated by everyone out there on the pitch. At least I like to hope so. I also love craft beer and the restaurant scene in Central Oklahoma. It's actually a really hopping restaurant craft brewery scene, for those of you that might not know. So I love to hang out with my friends and check out those places and see what's hopping out there. And then the last thing that I would be remiss if I didn't say was that I am a proud owner of 2 cats. So I'm a cat dad, and they have been the best work companions. No one's sitting on my lap right now, but it's quite common for one of them to be sitting on my lap during Zoom meetings and things like that. So I've been grateful to have their companionship while I work from home for the last 1.5 years. So that's a little bit about me outside of my work.
I enjoy going on hikes, like most people say that, I would say. I enjoy dessert, so I really like looking at all of the places around Oklahoma City that sell cookies and figuring out which place sells the best cookies. And then I also just got a new kitten named Pancake, and I bought her a harness with a leash. So it's my hope that I could make her into one of those really cool cats that can like walk outside on a leash and like hang out at restaurants and stuff that allow pets. So that would be really cool if she was open to that, but time will tell.
When I'm not in the office, I enjoy spending most of my free time outside. After work, I find it's very refreshing to go out and go for a run, go out and run 3, 4, 5 miles after work. On the weekends, I try to spend as little time at my house as possible. Since I live here in East Tennessee, I'll go out and I'm usually hiking somewhere or backpacking or kayaking or paddleboarding. Really, you name it. I love doing stuff outside. As an example, last year I finished map marking all the trails in the Smokies, which required over about 1,000 miles of hiking. So that consumed pretty much every one of my weekends last year, which was fun. And yeah, this year I do a little more, again, more diverse activities, but really anything outside. I just love being outside.
So I would say no matter where you're at, whether you're in middle school, elementary school, high school, college, just get involved. Seek out meteorologists. You'll find that we love to talk about the weather, just like you do. Be involved in student groups. There's lots of good student groups, not only at OU, but all sorts of universities around the country. Look for research opportunities. If you're interested in research, talk to professors and see what projects they're working on. They may have stuff for you to work on, and you can get experience doing that. If you're interested in forecasting, go to your closest National Weather Service forecast office, volunteer there, talk to the forecasters. Just talk to as many people as possible, get as much experience as you can, and who knows where it'll lead you.
My advice is pretty twofold. So on the more hard science skills, I would say programming is very applicable to many different careers in meteorology and outside of meteorology. So if you can get any experience programming, that will really serve you well for many different paths within meteorology. But conversely, we also really need good communicators in science. So we can have these ideas and we can think about them all we want, but if we can't communicate them and then execute the science and communicate our results, the impact is going to be severely lessened. So I would say work on those programming skills, work on those communication skills, and I think you would be a great fit for CIWRO in the future.
Another thing I probably should have mentioned when I talked about what I did for my job is I should have mentioned that I also spend a lot of time teaching classes and mentoring graduate students. So as part of that, I've seen those who are successful when they try to pursue activities related to atmospheric science and those who are less successful. And I would really say the most important thing related to having success in the career you pursue is doing something that you are interested in and passionate about. I feel truly fortunate that I don't sometimes think that I have a job. Rather, I get paid to do my hobby, which is to teach students and learn more about clouds. And another thing just to remember, it's very important that you study hard and do well in school in many different subjects. In order to work on our projects within CIWRO, you need to have skills in math, physics, writing, oral communication, and chemistry. And finally, learn something about computer programming, because computer programming skills will be very important for any job you want to do with CIWRO. And another final key thing is there's many different jobs you can do to contribute to the mission of CIWRO. You could act as an administrator, you could act as a computer programmer, you could act as a scientist, or you could do what we call research to operations. Figure out how to take the results of our research that we perform and make them into better operational products that will be used routinely to save lives and property. Figure out what interests you most and pursue that dream.
Conducting weather and climate research really takes all kinds of people, from scientists and engineers to software developers to research administrators to social scientists, to make everything run. So you can be interested in weather and have a passion and communication and still fit in here. Or me being a chemist, have an interest in the weather and passion for chemistry and still fit in. So it's a really big umbrella in atmospheric sciences and weather for you to have passions that aren't necessarily just science. So if you're really interested in pursuing weather, you can still do your own. So you can just do what you want and see if it can get you into science in a different way. Also, if you really think you're interested in doing research as a career, talk to professors in your program about doing undergraduate research, or look into the atmospheric science research experience for undergrads or REUs. They're one of the best ways for you to get exposure to new areas of research. And that's how I got into research in the first place. Is I would have never thought research would have been a career for me if I didn't get into that. And it's what inspired me to go to graduate school, and is largely why I'm here.
Probably the biggest piece of advice I can give that speaks most to me too is there's no right path and there's no wrong path. And Pat, I'm so glad that you brought this up earlier, the fact that I did go to Penn State and OU, which are two of the biggest programs in the country and in the world. And I got all three of my degrees in meteorology. It's quite a boring story. A lot of people have similar stories of going to big programs and getting meteorology for all their degrees. That's not the right way to do it. It's a way to do it. And just because it's probably the way that a lot of people do it doesn't mean that the other ways are the wrong way. I have several friends who have obviously gone to other institutions, smaller institutions that have graduating classes from, I don't know, anywhere from a couple students to 50 students each year. And then I also have several friends who have degrees in things outside of meteorology, whether it's another science related field like physics or mathematics or something like that, or even something outside of meteorology altogether. So the quick example that I want to give is with respect to stuff that I do with tornado warnings. So one thing that inspires me to do the work that I do is that eventually I like to think that my work will better protect people's lives and property that are in the face of tornadoes or in the path of tornadoes. But my work is only very indirectly really related to that goal. You know what's more directly related to that goal is social science, for example, and better understanding how people, one, receive tornado warnings, and then also subsequently act on those tornado warnings, hopefully to make life-saving decisions so that they can protect themselves from the tornado. My work doesn't begin to do those kinds of things, but that work and that social science work is just one example of how fields that are kind of on the outskirts of meteorology can really have a huge impact in the short term on some of these huge goals in the meteorology field, like better protecting people's lives and property that are being impacted by tornadoes. So it's a more long-winded answer than I had originally thought. But long story short is that there's no right path, there's no wrong path. The only right path is your path. And find your passion and follow that passion. And that will lead you to succeed, whether it's in meteorology or atmospheric science or in CIWRO in particular, which is the example that I just gave about tornado warnings. A lot of those folks that do that sort of work in the Weather Center work at CIWRO, and many of them have degrees that are not in meteorology. So that is one example that is relevant for CIWRO too, if that's something that you're interested in. So follow your passion and you will succeed. There's no right or wrong way to do it.
I would say to plan to take at least a few coding classes in college if possible. It's important and useful in nearly any facet of atmospheric science, especially if you plan on going to grad school, and it'll also help you stand out when you start applying for jobs in your field. I didn't take any computer science classes in undergrad, and then in grad school I was kind of just thrown into it and had to figure it out. So I know at OU they have you take computer science classes along with your meteorology classes, so that's really helpful. But if you're at another school that maybe doesn't have such a good, strong meteorological background, just know that computer science class is important, regardless of what you're looking to get into in the weather field.
The big thing is taking as much math and science as you can take. I mean, you probably hear that from many other folks, but I really want to harp on that point there that you can't take enough math. I mean, that's just such a critical thing for what we do. But also equally important is computer programming. Whether one's working at CIWRO, within NOAA, or wherever, that's a skill which is so important across the board, no matter what career one ends up doing. So computer programming, mathematics, and science would be the main takeaways there.